BVS Pragati channel welcomes you. In this session, let's have a look at rectifiers. Rectification, converting AC to direct current. There are three types of rectifiers: half wave rectifier, bridge rectifier, full wave rectifier. In half wave rectifier, what we are seeing is the diode conducts during only the positive cycle of input signal. So the input sinusoidal signal is applied at the input. This is induced to the secondary of transformer. Now during the positive period of input signal, what happens? The voltage is above cut-in voltage of the diode, and it conducts. So the current flows, and there's a drop across the load resistor, which is VL. So we see that during the positive cycle we get VL, and during the negative cycle the diode is cut off, so there's no voltage, and again during the positive cycle you see the voltage. Okay. So diode is connected in series with load resistor. In the above circuit, what we are saying, diode is forward biased during positive cycle and is reverse biased during negative cycle. And some of features, regulation is V no load minus V full load by V full load. So ideally V no load should be equal to V full load. But what happens in practical scenarios, that's not the scenario. Ideal regulation, the regulation is 0%. What we are seeing that the output is not a perfect DC, rather it is a time varying signal. So to get a perfect DC, what we do is we use filters to generate DC output. So this process of using filters to generate DC output is called regulation. So let's understand few filters. So capacitor filter is used when load currents are low and output voltage is high. Inductor filter is used when high currents are seen at the load and output voltages are low. The regulation of LC filter is better than pi filter. Regulation of capacitor filter is poorer than inductance filter because as load current increases in a capacitor, what happens? Output DC voltage falls and ripple voltage increases. What is peak inverse voltage? Peak inverse voltage of each diode in power supply with any type of filter in half wave rectifier is EM. So let's have a look at some more features. So important characteristics of half wave rectifier. Ripple factor is in fact a measure of the remaining alternating components in filtered rectified output. So it is the ratio of effective value of AC component of voltage or current present in the output from the rectifier to the DC component in the output voltage or current. So ripple factor is equal to IAC by IDC, which is equal to IAC is IRMS square minus IDC square by IDC square. So when you arrange the components, IRMS by IDC whole square minus 1. So this IRMS by IDC is KF, which is called form factor. So what is IRMS? I max by 2 and I average I max by pi. So KF is equal to pi by 2, which is 1.57. So ripple factor is equal to 1.57 square minus 1, which is 1.21 for half wave rectifier. Let's have a look at other characteristics. Peak inverse voltage. Peak inverse voltage rating of a diode is important in its design stages. It is the maximum voltage that the rectifying diode has to withstand during reverse biased period. So PIV of half wave rectifier is Vs max, that is the peak value of sinusoidal signal. Average and peak currents in the diode. So I max is equal to V max by RFD plus RL. RFD is forward resistance of the diode. RL is the load resistance of the diode. Let's have a look at some more important properties. So what is the DC output current that we are getting? So we see that during the entire cycle, IDC is equal to 1 by 2 pi integral of 0 to 2 pi I d omega t. ID is the current, I max into sin omega t d omega t. Okay, plus 1 by 2 pi integral of 0 to 2 pi 0 d omega t. So what we get? I max by pi. Okay, so what is the DC voltage? The DC output voltage is IDC into RL. IDC we see is I max by pi, and Vmax by pi into RL by RL plus RF. So arrange the terms. Vmax by pi into 1 plus RL by RF. If RL is far greater than RF, VDCC is equal to VDC is equal to Vmax by pi. So RF is forward resistance and RL is load resistance. So what is the DC output voltage? VDC is equal to, this is small correction, VDC is equal to IDC into RL, or VDC is equal to Vmax by pi into RL by RL plus RF. If you rearrange terms, Vmax by pi into 1 by 1 plus RL by RF. So if RL is far greater than RL, the numerator is less than the denominator. So we see that it becomes Vmax by pi. RMS value of current through diode. IRMS is equal to Vmax by 2 into RF plus RL. RMS value of output voltage across load is VRMS is equal to Vmax by 2. So what is the rectification? It is the DC power delivered to the load by AC input power from transformer, which is equal to PDC by PAC. Let's calculate PDC. It is IDC square into RL. IDC is again Imax by pi whole square into RL. Now calculate PAC. PAC is equal to power dissipated in diode junction plus power dissipated in load resistance RL. So IRMS square into RF plus IRMS square into RL. So Imax square by 4 into RF plus RL. So efficiency is equal to PDC by PAC, which is 4 by pi whole square, RL by RF plus RL, which is 0.406 by 1 plus RF by RL. RL is far greater than RF. So it is equal to 0.406. So maximum efficiency is 40.6%. Let's have a look at full wave rectifiers. So in this type of rectifiers, we see that, so if the input signal is applied over here, the sinusoidal signal appears across this point. So the signal over here is 180 degree out of phase with this. So it will be like this. The positive cycle will be like this. Here it will appear like this. So the diode D1 conducts and the current flow is due to diode D1 in the positive cycle. Now during the negative cycle, what happens? This diode D1 is diode D1 is off and diode D2 is conducting. So it turns on. So what happens? The current flow is due to diode D2. So we see that current flows through the entire cycle of input signal. So we get this sort of output voltage waveform. What is the disadvantage? Large transformer for a given power output is required with two separate but identical secondary windings, making this type of full wave rectifying circuit costly. To overcome this problem, full wave rectifier is used. Center tap transformer is required. What is PIV? PIV is twice EM. What are the advantages of full wave rectifier? Efficiency is twice half wave rectifier. Ripple is less and ripple frequency is double, and less. Since ripple frequency is double, you need less value of capacitors and inductors. And what do you get? More DC output voltage, low AC component. So let's understand the differences between series regulation and shunt regulation. In series regulation, we see that the transistor diode is in series with the load, and in shunt regulation, the diode is in shunt with the load. So maximum power dissipation of the transistor when load current is maximum. In shunt regulation, maximum power dissipation of transistor when load current is 0. In series regulation, no dissipation when there is no load current. Minimum, in case of shunt regulation, we see there is minimum power dissipation when load current is maximum. So unregulated power supply is not preferred due to high output resistance and poor main voltage stability. Let's have a look at full wave bridge rectifier. In full wave bridge rectifier, what we are seeing? We are seeing there are 4 diodes connected in closed loop bridge configuration produce desired output. So during positive half of the input signal, diode D1 conducts, and since the same thing appears as a negative over here, diode D2 also conducts. So D1 and D2 conducts, and the signal current flows through like this. And you have output voltage. Okay. And diodes D3 and D4 conduct during negative half cycle. Okay. So diode D3 and during negative half cycle, what happens? So when it is negative, this is P, this is N. So this conducts. So negative is connected to this. So this conducts. Here this is positive side, and this also starts conducting. So diodes D3 and D4 conduct, and hence there is output across the load. So you use smoothing capacitor, which this is a smoothing capacitor. This removes ripples. So this is how the output appears. Okay, this is the resultant output waveform. We see that this is waveform without capacitor. So if you have, this is waveform with capacitor, we see that the AC component is removed and you have only DC component. What is the advantage of bridge rectifier over full wave rectifier? The peak inverse voltage is EM, no center tap transformer is required. Disadvantage is there are 4 diodes, voltage drop across each diode causing low output voltage and poor regulation. So let's have a look at various power. We have seen various power supplies, and now let's have a look at the comparison of power supplies. So this is half wave rectifier, this is full wave rectifier, this is bridge rectifier. What is IM? EM by RD plus RL, EM by RD plus RL. In bridge rectifier, since there are 2 diodes, twice EM by RD plus RL. IDC, IM by pi, twice IM by pi, and this is twice IM by pi. IAC, IM by 2, IM by root 2 in full wave rectifier, and bridge rectifier also IM by root 2. What is the no load voltage? EM by pi in case of half wave rectifier. Full wave rectifier, it is twice EM by pi. Bridge rectifier, twice EM by pi. Full load voltage. IDC into RL in half wave rectifier, IDC into RL in full wave rectifier, and IDC into RL in bridge rectifier. Regulation is RD by RL in half wave, RD by RL in full wave, and in bridge rectifier twice RD by RL as there are 2 diodes. So similarly other characteristics. That's all for this.